Hello, welcome to another day of the Pythagorean Theorem. You guys are very excited. So up until now, you guys have been working with triangles. Today, we're going to talk about three-dimensional shapes, specifically rectangular prisms. And there is an aspect of the Pythagorean Theorem that we can use to solve for the diagonal length of a 3D prism like this. So this is a diagonal that comes from the front left corner to that back right corner. So it's traveling three-dimensional space. Okay? Now, whenever we talk about 3D shapes, we usually talk about a length, a width, and a height, right? So in order to make this make more sense with the Pythagorean theorem and stuff like that, I'm going to, instead of labeling them L, W, H, I'm going to label them A, B, C. And I'm going to label this diagonal length as D. Now, I'm on page 39. I should have told you that before, but I'm on page 39. So you should turn to page 39 if you haven't already, and then pause the video and draw this little sketch. And then we're going to go through and prove a theorem here. This is an offshoot of the Pythagorean theorem. This is the 3D Pythagorean theorem. Okay? So if I wanted to find this diagonal length, okay, and I wanted to use the Pythagorean theorem to do it, I would need the two legs. That would be like the hypotenuse. The height would be a leg, and then the diagonal going across the base of the rectangle would be a leg. That would be a diagonal triangle, right? Cutting through the three-dimensional space of that rectangle. The problem is I don't know this length, right? But I could use the Pythagorean theorem to figure it out, right? I don't know these lengths right now, but if I do know that a squared plus b squared would equal that length squared, right? So a squared plus b squared, and I'm just going to call this x for now. Okay? So I'm going to call that side x, and that's equal to x squared. Okay? Then, to figure out what that side length is equal to, I would have to square root, right? And I'd have to square root both sides. So x is going to equal the square root of a squared plus b squared. So I can take out this x here now and replace it with this side length is equal to a squared plus b squared. Okay. I mean, that's great, but how does that help me, right? So I'm zooming in here a little bit just so you guys can see this in a little finer detail. So basically, I figured out that this diagonal that goes across the bottom would just be the square root of both those sides squared added together, right? That makes sense from the Pythagorean theorem, because a squared plus b squared would equal that side squared. Okay, and then you square root to get rid of it. So I've got that. So that's going to set up another triangle. That gives me this diagonal triangle. So again, using the Pythagorean theorem, I would do the square root of a squared plus b squared squared plus c squared would equal d squared. Now don't worry about this right now. I'm just kind of showing you what this formula is. I'm deriving the formula. This is not stuff that you will have to do. It is much easier than this. But I'm just trying to show you guys what the formula is and how it works. Okay? So I have set up this triangle here. Now when I square a square root, what happens? Well, the square root and the square cancel each other out, right? So I'm going to be left with a squared plus b squared plus c squared equals d squared. And that is my three-dimensional Pythagorean theorem. Okay, so basically what that is saying is if I take the length, the width, and the height and square them, add them together, it's going to equal the diagonal squared. Okay? So pretty much the same thing, just added another thing here. but all we need are these three lengths, and then we can get that diagonal. Okay? Same process was Pythagorean theorem where you squared the legs and added them together. You're going to square the sides. Okay, and it doesn't matter what you call the length, the width, or the height. Like, they're all interchangeable, right? You're squaring them, adding them together. Okay, let's go through an example, and let me show you guys how this works. So turn to page 37, and I'm going to go through and give you guys some steps here. Okay, so first step is number 1, identify your length, width, and height. Okay? Well, you should probably be able to move it so you can see. Identify your length, your width, and your height. Next step, plug into 3D Pythagorean theorem. Okay, then after that, we are going to square and combine like terms. And then the last step is to square root. Okay, so those are our steps. So now I'm going to apply those to a problem here. So I'm on page 37, and first thing I'm going to do is I'm going to identify my length, my width, and my height. So length, and again the 3D Pythagorean theorem is a squared plus b squared plus c squared equals the diagonal d squared. Okay? So if I want to find this diagonal length, okay, I need to find a length, a width, and a height. So length would be 7, so 7 squared. Width would be 3, so 3 squared. Plus a height, which is 2, 2 squared would equal the diagonal squared. Okay, so then I square those. 7 squared is 49, 3 squared is 9, 2 squared is 4. That's going to give me 58 and 62. 62 is equal to the diagonal squared. Okay, still not quite done because I need to figure out what the diagonal is by itself, not the diagonal squared. So I'm going to plug in 62, or the square root of 62, in my calculator, and I'm going to round that to the nearest tenth. So 7.87 would round to 7.9 would equal the diagonal, and that is my answer. Okay, not that tough, right? Again, length, width, height. Like to set up this one, it would be 4 squared plus 2 squared plus 4 squared equals the diagonal squared. Okay, not too tough, right? Length, width, height, square them, add them together, square root.